Good afternoon, everybody, and welcome to our Reef Water Quality Improvement Plan Review Seminar series. Today we're going to talk about how we manage vegetation in reef catchments. We've got, again, another amazing bunch of presenters for you. So we have Peter Lazzarini and Lisa Gale from the Department of Resources, Tom Webster from the Department of Environment, Science and Innovation, and Misko Ivazic from Alluvium Consulting, and they're going to take us through the journey on how we manage, protect, and restore vegetation in Queensland in reef catchments today. So really, really great speakers. Before I kick off to Pete, I'll just do an acknowledgement of country. I'd like to, next slide, please, Sybil, pay my respects to the Turrbal and Yagara people whose country I'm on today. I would also like to extend my acknowledgement to the traditional custodians of the land and sea country of the Great Barrier Reef, as well as from where you're joining us today. If you're a First Nations person, I would also like to acknowledge your elders past and present. And I'd really like to acknowledge 65,000 years of vegetation management practices in this continent and how much we can learn from that. I was watching a presentation on fire management and the importance of fire management from a vegetation management perspective, and really thank that traditional knowledge and think of that in the context as we move forward with this review. So without much further ado, I will pass on to Pete.
Thanks, Maria. And are we keeping questions, just to confirm, we're keeping questions to the end, then we have an open forum?
Yes.
Is that right,
yes.
Maria? Yes. Yep.
Absolutely.
Good.
If you have any questions throughout the presentation, just pop it in the chat, and at the end, we'll answer all the questions there.
Okay. Thanks, Maria. Hi, everyone. My name is Peter Lazzarini. I'm Director of Vegetation Policy in the Department of Resources. Our department administers the Vegetation Management Framework, and that the main piece of legislation under the framework is the Vegetation Management Act that regulates clearing of woody native vegetation in Queensland. It applies across all tenures except the protected area state, like national parks and state forests, because they're regulated under different legislation. And the framework, the thing we call the Vegetation Management Framework, includes the Planning Act and associated regulations and codes, and is very much based on statutory maps, which I will show you some examples of. The Veg Management Act has a number of purposes that are up on the screen there, and that ranges from conserving remnant vegetation through to reducing greenhouse gas emissions and allowing for sustainable land use. Thanks, Sybil. Next slide. So just some key stats to give you context of Queensland, which is a big place, which is about 173 million hectares. About 80% of Queensland is mapped as some form of regulated vegetation. The majority of that is remnant vegetation, or a category on our statutory map called Category B. It also includes smaller areas of regulated regrowth vegetation, as well as reef watercourse areas. About 20% is areas where no approval is required to clear woody vegetation, and the largest area there is that 33 million hectares of Category X. And there's also some extensive areas of native grasslands that don't generally have much woody vegetation on them. Okay, next slide, thanks. So if we look at just the Great Barrier Reef catchment and those same breakdown of statistics, so the GBR catchments are about a quarter of the state. They make up about a quarter of the state, or 42 million hectares. About 26.7 million mapped as regulated vegetation, mostly remnant vegetation, with again those smaller areas of regulated high value regrowth, reef watercourse areas, and those category A areas, which are restoration type areas. The category X component of that is about 15 or almost 16 million hectares. So just to show you what that looks like on a mapping, from a mapping perspective. So the middle map there is the statewide view of our regulated vegetation management map. So that dark blue is the area of remnant vegetation. You'll see a lot of the category X, which is the white areas, are very much, areas where there's been major clearing for agricultural development, grazing and cropping areas. Then the map on the right shows that same, drills in and shows that same breakdown of the regulated map across the reef catchments, with the majority of the remnant or category B vegetation in the northern part of the reef catchments, and a greater proportion of category X in those southern, the southern part of the reef catchments. So if we look at those categories and an example there of what they might look like on the ground, so it's over an image base, and you'll see the darker blue area there is the remnant or category B vegetation. The lighter blue or almost greeny colour there is an example of the high value regrowth or category C vegetation. We have the yellow reef watercourse area, and then the red area is the category A or restoration areas, and that can be either where land has been unlawfully cleared and requires restoration, or where someone has voluntarily entered into some sort of a restoration project or an offset. The areas where there's no colour is the category X areas, where there's no requirements under the veg management framework to clear vegetation in those areas. So this diagram here just shows, represents how the framework applies. So if we start in the top left corner, there's certain clearing that can be done without any approvals under the veg management framework. So that's called exempt clearing work, and that's generally for things that are either for safety purposes, such as clearing for fire breaks, or maintaining existing fences and infrastructure, and category X vegetation also sits in that area. The next quadrant around is called accepted development. So there's certain things for low risk clearing that can be done under a self-assessable code, and there's a number of different purposes where people are required to make a notification to the department and then follow the requirements of the code. Some of the key things are for the reef catchment areas would be things like selective harvesting under Native Forest Practice Code, undertaking weed control, constructing property infrastructure, some examples there. And then the next quadrant round is called accessible development, and that's for higher risk clearing. So that's for things that higher impact than the self-accessible codes allow, and that's an application and approval process. And then the last quadrant there is everything else. So if you can't undertake your clearing through one of those other quadrants, it's prohibited development. And this, I guess a note here is this is just how the vegetation management framework applies. There may be other laws, state, Commonwealth or local government laws that also continue to apply and may affect what clearing can occur in any of those particular quadrants. So I'll hand over now to Lisa to take you through the next part.
Hi everyone, my name's Lisa Gale. I'm one of the managers with the Vegetation Management Unit at the Department of Resources. So I look after our compliance area of business, And at the department, we do regulate across a continuum of risk level. So we start at one end where we really try to work with the landowners and stakeholders to guide and inform them about what the legislation is and how they can comply, through to prosecution at the far end. But in between, we do have tools available such as penalty infringement notices or restoration notices and some other tools as well. We really do try and work with landowners in the first instance to educate them and help them understand what their obligations are and how they can comply with the framework. The prosecution at the other end is really sort of the last resort, if you like, and we do it on a risk-based approach. So we look at the individual and their behaviour. So are they willing to comply and they just either didn't know or just got it wrong, or are they really just doing it on purpose and deliberately? And then also, what is the actual impact to the environment and on the resource that's resulted from that activity? So there is that continuum that we have. Next slide, please. So the main way that we look at or detect non-compliance is through our early detection system. So this is a satellite system in the sky where every 2 weeks it identifies vegetation canopy cover change across the state. So every fortnight we'll get a bunch of detections come into us, which we'll look at. So in the top left-hand corner there, you can see very faintly there's sort of a black outline in the midst of that treed area, which shows the detection. And then the top right, you can see that same outline. So post-clearing, you can see that vegetation has now gone. Bottom right-hand picture shows higher resolution imagery where you can more clearly delineate the area where the cover change has occurred. And then the bottom left shows what it might look like on the ground. So from the desktop, we can actually see quite a lot of vegetation canopy cover change through our EDS system. So on average, or last financial year, we had about 1,800 detections that we looked at through the system, and of those we found that about 25% of them couldn't be explained through the framework. So what Peter was just talking about of exempt clearing work or accepted development. So next slide, please. So this shows you what our officers look at. So this is from our EDS system. So the blue outline area is the area where there's been a detected vegetation cover change, and our officers would look at that and they would see if in the first instance, can we explain it? So is it caused by a natural cause such as a fire went through, or maybe it was a drought, or at the end of the dry season in some areas the trees drop their leaves, and that does get picked up through our EDS system. And if you move to the next slide, it sort of shows the afterwards. So in this instance, our EDS detection picked up a portion of the cover change, but from our analysis, we were then able to see actually a lot more canopy cover change has occurred. And you can see it's clearly sort of vegetation that's been stacked up in little piles. So once we determine that it is a man-made occurrence or cause of the cover change, we can then look at those exemptions. Does it meet an exemption? Is it acceptable development? Do they have a permit for it? Or does it actually fall within that prohibited development from Peter's slide? So next slide. So yes, so this is what we investigate a little bit further. So we've got it's an example of some detected clearing just on the edge of where those trees are. We can then look at some high resolution imagery to see what is actually going on. And you can see from the high resolution imagery, it is really clear to and easy to pick out individual trees, but also in that yellow square, we can actually see in some instances what's actually happening on the ground. So in this case, there's 2 dozers and a chain between them. That would be the method of the clearing. Next slide. So as I mentioned previously, we do like to engage with our landowners to make sure that they do understand the framework and help them to work through the exempt clearing work and the accepted development and any permits as much as we can, just so that they're aware of their obligations under the framework. So we do go out and do workshops, we run information sessions, we have stalls at field days. and we do partner with other agencies as much as possible to do that work. Last financial year, we attended 89 engagement sessions, and of those, about 20 of them were in reef catchment areas. So in 2022, the then Minister for the Environment convened a native vegetation scientific expert panel, and one of the aims of that was to look at how do we minimise the area of unauthorised clearing. The amount of unauthorised clearing does contribute significantly to our greenhouse gas emissions. So if we can reduce the unauthorised clearing, then we work towards reducing emissions as well. So one of the recommendations of the panel, and Tom will talk a little bit more about some of the other recommendations, but one was to increase the department's capacity to undertake its compliance activities. So we were given $9.8 million over 4 years to try and reduce the unexplained clearing, with a focus on that first lower end of the spectrum of getting out there, educating landowners, supporting them to comply before taking any further action. So we're just ticked over into year 2 of that program, and that's included hiring an additional 16 staff across the agency. So not just within the operational team, but also with our legal services and our investigations unit. And the first year has really focused quite heavily on that education, getting new staff up and running. And we've also undertaken a behavioural insights project just to understand how people understand the framework and what the best way is to communicate with them. And the next slide. So the final slide for myself is one of the best ways to communicate with us is our Veg Hub. So as I said, we do focus on that education and stakeholder engagement, and our Veg Hub is our key delivery mechanism to provide advice to clients on the vegetation management framework. So we do have a 135 Veg number and an email address, and we do encourage anyone who's got any questions about the vegetation management framework and what their obligations are to contact us on those numbers. So I'll hand back to Peter.
Thanks, Lisa. And so just to wrap up, I guess the vegetation management framework, how do we monitor performance and what's been happening? Well, in Queensland, we have been fortunate to have access to the statewide land cover and tree study, or SLATS as it's also known. And that's a program that's undertaken by Department of Environment, Science and Innovation. Has been undertaken for many years, and it has been monitoring woody vegetation changes over a long period. So that gives us some good information to help guide our policy. SLATS is generally released annually, and because of the sort of intensive work required to map the clearing, it reports on woody vegetation changes that occurred about 2 years prior. So I've got some examples here of what some of that data shows. So in the GBR catchments, in the last SLATS report, which was released in July this year and was for the period 2021 to 2022, 44% of Queensland's total detected clearing occurred in GBR catchments, and that was about 143,000 hectares. That was a 13% reduction from the year before, and about a 1/3 reduction from the 2018-19 figures. It was important to note that about 82% of that total clearing was in that Category X area, where no approval is required, and that Category X has been in place since about 2004 to provide landholders certainty about being able to manage vegetation in those areas. The SLATS report also now, since 2019-20, also maps and reports on woody regrowth that is growing back. So the bottom of the slide there shows how the areas of regrowth that's been mapped by Department of Environment in science. The graph on the right just shows the sort of trend of the different categories that we look at. One is that unexplained clearing, which you see is quite still proportionally high, which is one of the reasons why, as Lisa explained, we provided some further funding to try and reduce that level of unexplained clearing. The exempt clearing category there is for things that aren't regulated under the veg management framework, but require approval under other frameworks. So things like forestry on state forest, mining activity, etc. Then you'll see with our accepted development codes, the trend is generally has been down in recent years. Development approvals is pretty static and small, and area management plans is pretty small as well. So as I said, SLATS has been monitoring clearing over time, and this graph provides a historical perspective of what's happened since the Veg Management Act was first introduced in 2000. And across the top of the graph shows different legislative changes that occurred over time. The blue line on the graph is total clearing, and then the green line is the area of regulated vegetation clearing. So the difference between those two is the area of Category X clearing. So you'll see the regulated clearing, there was a big drop from the initial, when the Act first came in, through to about 2009-10, and then sort of gone up a little bit, but then, yeah, it's pretty well plateaued. The Category X total clearing did increase, but again, since 2018-19 and the last amendments to the Veg Management Act, there's been a downward trend of that area as well. Then the last slide I've got is just another way of, or another monitoring tool, and these are numbers from the Commonwealth Government's National Greenhouse Gas Inventory, and this is Queensland's total emissions from the different sectors. So when they measure the carbon emissions, it's from the different sectors which are listed on the right there. The emissions from vegetation clearing are included in that green area of the graph, which is land use change and forestry. And you'll see now that the emissions, Queensland now for that sector is a net sequester of carbon due to one of the main reasons is due to reductions in tree clearing that have occurred over time. So there's still certainly significant way to go to get that graph down to where we want to be by 2050, which is net zero. But it does, I think there's certainly some more opportunities to bring that graph down further. So I think that was my last slide. Thanks, Sybil. Yes, I'll hand over to Tom now.
Thanks very much, Peter. G'day, everyone. My name's Tom Webster. I'm a manager with the Queensland Government's Natural Capital Program, which amongst other things is responsible for delivery of the Land Restoration Fund, which is the Queensland Government's carbon farming scheme. This has already been touched on a little bit, but I just wanted to speak briefly about the recent independent review of native veg management in Queensland. So March 2022, this kicked off. The government established the Native Veg Scientific Expert Panel to independently review native veg management in Queensland. That was headed up by the former Queensland Chief Scientist, Hugh Possingham, and it was set up in response to clearing rates that were detected in 2018-2019 statewide land cover and tree studies reports. So the panel's report is out, it's online. I've provided a link to it at the end of this presentation, but you can also easily find it on Google, and there's a pretty good summary on that page of the report. The Queensland Government has committed to implementing the recommendations that are on the screen there, those 10 recommendations, over the next 2 years. My presentation today will focus on this recommendation 4 around enhancing carbon market opportunities So Sybil, we can probably go to the next slide, and I'll talk a little bit about the Land Restoration Fund. So this is Queensland Government's program for encouraging the uptake of carbon farming projects in Queensland. The LRF is promoting that uptake of carbon farming projects in two ways. The first is its commercial arm, and that's making investments in land sector carbon farming projects in Queensland that also generate these environmental, socioeconomic and First Nations co-benefits. I'll talk a little bit more briefly about the projects that we have invested in, but we've also got this second arm of work, which is about industry development. So that's the Land Restoration Fund making investments to help more people in Queensland get involved in carbon farming and access environmental markets. The key difference between the Land Restoration Fund and other schemes, other carbon schemes, is that we purchase the carbon credits and the associated co-benefits, as I mentioned. So the co-benefits, as almost all of you will no doubt know, are these positive environmental, socioeconomic and First Nations outcomes that are delivered by carbon farming projects, in addition to the carbon component. So some examples of co-benefits that the Land Restoration Fund would pay for. An environmental co-benefit would look like growing or retaining habitat for threatened species, improving water quality flowing to the Great Barrier Reef. Socioeconomic benefits, we're looking at jobs, skills and training in the local communities where projects take place. And the First Nations co-benefits, projects that take place on Indigenous land or benefit traditional owners, for example, through employment and through setting up ranger training programs and things like that. So those co-benefits make a project more valuable, and the Land Restoration Fund paying for those projects has meant that we've seen more expensive projects that would not necessarily have been possible under the federal government scheme, which pays for lowest cost abatement. Those high environmental value, high cost projects that involve a lot of plantings, for example, are made possible by the higher price point that the LRF is willing to pay for the associated co-benefits. The higher price point can also mean that landholders are required to sell fewer of their carbon credits to make a project viable. So in many instances, Land Restoration Fund projects would only sell us a small percentage, 30% perhaps, of the carbon credits generated by their project, and that's enough for them to make the project viable. They retain the 60, 70, 80% of credits that they haven't contracted to the LRF, and they can do with that what they wish, whether that be offsetting their own emissions or waiting to see what happens with the market and potentially selling them to another buyer further down the road. So the Land Restoration Fund occupies that place of bringing high environmental value projects online and supporting projects to get up and running without landholders having to commit the vast majority of the anticipated credits from a project. We've got this slide up on screen now that just shows a map of where the Land Restoration Fund projects are in Queensland. You can see there's a big spread along the east coast there. We currently have 20 projects contracted. Slightly more than 13,000 hectares of CADEX land is contracted for avoided clearing projects, human-induced regeneration and environmental planting projects. It's anticipated that the projects will result in the delivery of slightly more than 1 million carbon credits. So that's 1.15 million tonnes of greenhouse gases sequestered or avoided being released into the atmosphere. And of those 20 projects, 13 of those come with a Great Barrier Reef co-benefit that the Land Restoration Fund is paying for. And in brief, Great Barrier Reef co-benefits are for projects that can verify improvement to veg condition in Great Barrier Reef catchments. The Land Restoration Fund has this very useful, quite dense document called the Co-Benefit Standard that sets out the requirements for verifying all the different co-benefit types and categories. That's on our website, and you can have a look at that to see the sort of co-benefits that we pay for and the kind of evidence and verification projects we expect in order to accept and trigger payment for those co-benefits. We'll jump to the next slide. So talk a bit about, that previous slide was about the commercial investments that we make in carbon farming projects. And I also mentioned this other arm about growing markets in Queensland. I'll just touch on a recent example of some of the work that we've done there, which has been to contribute to a process of bringing new methods online, new carbon farming methods online. So in July earlier this year, we, the Land Restoration Fund, submitted ideas for 2 new methods to be developed under the Australian Carbon Credit Scheme. One was an integrated reforestation and avoided reclearing method, and the second one was an improved avoided clearing of native regrowth method. That second one, the avoided clearing of native regrowth method, we ended up progressing through an expression of interest process, and to properly formally submit that through that process, noting that such a method could form part of a broader integrated method to bring together project activities on comprehensively cleared land under a single project method. So that EOI process is submitted now and goes through to the Australian government, and it's their decision of whether or not to prioritise it. If prioritised, we anticipate that such a method would broaden eligibility for carbon farming in Queensland, remove some barriers that we know currently exist, and better incentivise the retention of regrowth native forests, and hopefully provide Queensland landholders with some additional an opportunity to avoid clearing that native regrowth. There's a bit to go through before we know what happens with that method. So the Emissions Reduction Assurance Committee, ERAC, will meet to consider that submission. Our EOI is one of 39 that have been submitted, and they've only committed to shortlisting between 3 and 5 of those 39 new methods for development. So we'll kind of wait to see if we've been successfully shortlisted, and in the event that we are, we work with the Commonwealth to develop that method and bring it online. There is another link at the end of these slides to the method development tracker, where you can see all the methods that have been put forward across Australia for consideration, including the one that I've just discussed here today. That's it for my presentation. Feel free to keep putting questions in the comment box there, and otherwise I'll hand over to Mishko. Thanks.
Yeah, thank you. So my name is Mishko Vasic. I'm an engineer, specialise in river management and understanding how rivers change their shape and form. I guess one of the key things I do as a river engineer, designing sort of river rehabilitation plans or strategies to help try and create conditions for riparian vegetation to sort of re-establish within our river channel. So I'm talking a little bit about that today. I'll talk a little bit about river erosion, its impacts, and the role of riparian vegetation in limiting erosional processes in river systems, particularly the Great Barrier Reef catchments, and also introduce some case studies of evidence around vegetation and also revegetating streams to help erosion. Next slide, please. So these are some photos I quite often use to demonstrate the amount of fine sediments and nutrients heading out into the Great Barrier Reef. This is the very southern end of the Great Barrier Reef, and 2 river systems I work in quite close to the Mary River and the Burnett River. And a lot of that sediment is due to sort of poor riparian vegetation condition. And I think some of the estimates of the fine sediment loads coming out of these catchments are sort of 2 to 3 times higher than they were pre-European, mainly due to the degradation of riparian vegetation, which then leads to channel erosion. Next slide, please. So this diagram here is one I like to use to help describe channel erosion, if you like. So on the right side of the balance, we've got stream slope up the top and stream flow. And that right side is basically the energy or the force within a river system. And obviously, if you have a steeper river system, the water's going to travel more faster and have more power or energy. And similarly, if you have more flow in a river, you can have more energy or power. So obviously, you have more energy or power in a big flood event than you might do on a low flow day, for example. And then if you look on the other side of the balance, it's the resistance side of the balance. So a river uses its energy to transport all the sediment that comes through the river reach, so the cobbles and the sand and the gravels that may be transported through the river, and also to overcome the channel boundary resistance, which is primarily provided by the vegetation. And so when both these left and the right side of the balance roughly equal, we see a relatively stable channel. You get a bit of erosion here and a bit of deposition there, but you don't see wholesale, widespread channel erosion or deposition. However, if one of these sort of four variables, the stream slope, the stream flow, or the sediment spiral vegetation is altered, it can tip the balance in either an erosional phase or a depositional phase. Let's go to the next slide. And so when we think about how some of our catchments and riparian zones have been changed since European settlement, we've had catchment clearing, which has tended to increase the flow in the river. So that increases the energy side of the balance. We get bigger flood events, faster flowing water. We've also had a lot of clearing of riparian vegetation and unrestricted stock access, which reduces the resistance of the channel bed and the banks. And also, particularly in the Mare River, I talked about earlier, there's been widespread sand and gravel extractions occurred over the 20th century across many river systems across Queensland, and that destabilises the bed and also steepens up the slope. So all these changes tend to increase the force side of the balance, so you get more energy, more water coming down the river channels, more stream power, and then reduce the resistance side of the balance as well, which has led to sort of widespread erosional channel change. Next slide, please. So there's two different figures there. We'll talk a little bit more about the vegetation variable in that geomorphic balance. There's two different examples of river channels there. The top one, we've got really good ground covers and shrubs and large trees. And the bottom one's just got some sparse sort of grass cover. It's been impacted by grazing and some isolated large trees. And so I want you to imagine you're a water molecule in a flood event. You're traveling through both of those river channels. And if you're going through that top riparian zone, you're going to be banging into trees and foliage and getting shot all over the place. So you're going to exert a lot more energy trying to get through that densely vegetated channel than you are through a relatively sparsely vegetated channel down the bottom. I said, well, that's exactly the same as, oh, no, haven't finished yet, go back. And that's exactly what happens in river channels. So the flood exerts a lot more energy trying to get through all that vegetation, which means there's less energy available to erode the bed of the banks. Whereas a flood going through the bottom channel example, there's not going to be much energy exerted against that vegetation or lost overcoming all those branches and shrubs and foliage. So there's going to be more energy available to erode the bed and the banks of the channel. And so what we call geomorphically effective vegetation is structurally and age class diverse, similar to what you've shown in that top example there. And I'll talk, now go to the next slide, I'll talk what I mean by structurally diverse. So structurally diverse means you have grasses and ground covers, you have your small shrubs and trees, and you have your larger deep-rooted trees as well. And the reason why it's so important is because each sort of structural class does a slightly different role in limiting erosion within our river channels. So your bigger trees have deeper roots and sucker roots that really hold together the bank material, almost like steel and reinforced concrete. Your shrubs and your ground covers are better at scour protection. They sort of lay flat and quite malleable, and your grasses lay flat and they sort of armour those sort of clay or loamy sediments from that flow force. And then the hydraulic roughness, particularly your smaller trees and your shrubs, which have lots of density of small branches and lots of foliage that interact, have lots of physical elements that interact with the flow velocity, they're really good at dissipating that energy like I talked about on that last slide, which means there's less stream power available to cause erosion of the channel. Next slide, please. So there's a few studies across Australia. This is probably the most well-regarded one in the Great Barrier Reef catchments, looking at the role of existing vegetation. So areas of riparian zones that hadn't been cleared and comparing the erosion to areas that had been cleared. And this is a study done by Beck Bartley as a CSIRO. I was on the Daintree River and found that there's a sort of significant, what's the stat there? So 6.5 times more erosion on areas that had been cleared compared to areas that had retained their vegetation. There's been similar sort of studies done in southeast Queensland as well. But interesting, there has been very little studies looking at actually the benefits of revegetating streams. So finding a degraded river reach, investing in revegetating that stream and getting vegetation to grow, and then going back and assessing the impact of those revegetation works. Mainly because it's difficult to assess, you need long sort of study time periods. But it's interesting because literally millions of dollars have been spent across Queensland and within Great Barrier Reef catchments within revegetating riparian zones. So next slide, I was involved in a study a number of years ago down with the Victorian government after the 2011 flood events that hit northeast Victoria, where we went and found a whole lot of reaches where the Victorian government had invested in revegetation programs in the sort of late 90s. So we had a sort of 10-year gap before the flood. And so we could go back and assess those reaches that had the revegetation program, and we assessed it against a paired site, either upstream or downstream, which had similar river characteristics, but didn't have the revegetation program. And this is an example on Black Range Creek in the northeast of Victoria. We saw widespread erosion on the channel on the right and a relatively stable channel on the left. So if I think back to the geomorphic balance, everything else is the same between these two paired reaches, but one has better riparian vegetation. That vegetation was able to resist the stream power and not cause erosion. And similarly, the next slide, this is Barwidgee Creek, which is not too far away in northeast Victoria. And we see that downstream reach with widespread widening of the channel in that flood event, and then further upstream, it was a stable because the vegetation held it together. But other than that study, there hasn't really been too many up until this next study I'm going to talk to you about. The next slide, which is on the Mary River, which is a recent study I've been involved in. And I've been involved in this, managing this reach for the last sort of 10 years. So sort of going back to 2015 and after the floods in 2013, and we came up with a management plan for this reach of river, the Mary River, adjacent to Kenilworth Township. You may know Kenilworth. You can see Kenilworth in the background, the top image there. And so it's sort of widespread, massive erosion in those flood events, particularly in 2013. Some of these banks migrated like 50 to 70 metres across the floodplain. There's 12-metre high banks you can see in that top image, near vertical. And they're just getting erosion of the toe and then slumping it, and shown on that conceptual diagram on the left. So literally, thousands of tons of sediment being eroded from this area, huge areas of valuable agricultural land being washed down the river. So we just got down with a range of stakeholders and came up with a management plan, which involved, in some areas, reprofiling the bank as shown on the right there, installing these timber piles along the toe to help slow down the water, and then actively revegetating the bank. So that was only the really actively eroding banks, and then in all the other sections in between, there was just typical sort of riparian fencing and revegetation programs, which didn't need that sort of soft engineering intervention. And so various stakeholders were involved investing in the program of works, including money for the Great Barrier Reef, including SQ Water, who runs the offtake for the township. And so it was a really successful multi-stakeholder investment strategy, but it didn't take long for these works to be tested out. If you go to the next slide, in a couple of years ago in 2022, there was a very wet year. There was a series of floods, and the biggest flood was in May, and that flood was actually the biggest since the 1990s. It was the biggest, bigger than the floods in 2013, which caused all that widespread erosion and migration of the channel. And so it was a nervous weekend for many of us involved in the project, because we finally got to see whether the works and these extensive revegetation works that were implemented in the preceding 5 or 7 years had a role in stopping the erosion. Last slide, the next one. I guess the good news is they did. So you can see all the various sites throughout the reach through there, before and afters on the left, befores on the left, and then the corresponding after photo on the right, taken earlier this year or a year or so after the flood. But all the reach held up really, really well to this very large flood event. We've been able to collect a whole lot of LiDAR data and topographic data since the flood, and compare it to the pre-flood data, and found that these works stopped almost 90% of the erosion that we would have been expected based on the erosion that's occurred in the preceding 50 years during flood events. So it proves that riparian vegetation is really, really effective, or revegetation in particular. So these, you see the difference in only a few years between the left and the right photos, and that was able to stop all that erosion. So it is really good at stopping erosion, but as we know, it provides a whole lot of other biodiversity outcomes as well, and social outcomes as well. And just key 2 points there is, vegetation should be structurally diverse. It can't just be grass and it can't just be trees. You need to have all those different structural elements, from ground covers, shrubs and trees, because they all do a slightly different role, and they all provide different ecological functions as well. But you can't just, in some cases, some of those big vertical banks you can see on those photos on the left, you can't just revegetate those. There are situations where you are going to need some soft engineering approaches, some earthworks to reshape banks and put in logs or piles to help the vegetation get established over those sort of initial 5 to 10 years. And then after that, the vegetation can do all the work. Thank you.
Thank you so much, Pete, Lisa, Tom, and Mishko. That was amazing. An amazing overview of vegetation management in reef catchments.